Assalamualaikum and hi everyone. So in this video we are going to continue our discussion in chapter 4 chemical bonding. Okay, so chapter 4.4 intermolecular forces. Alright, so let us check what is the learning outcomes for this topic. So at the end of this lesson you should be able to describe the intermolecular forces, which is the first one is van der Waals forces. Okay, van der Waals forces can be divided into two: dipole-dipole interaction or permanent dipole, and London forces or dispersion forces. Right, next we're going to discuss the hydrogen bonding. Okay, and then let us look. Intermolecular forces are the attractive forces that exist between the molecules. Okay, so intermolecular forces ialah daya tarikan yang wujud di antara molecules. So let's say we have one HCl and another HCl. So these two molecules have weak intermolecular attraction, which is known as intermolecular forces. Okay, so intermolecular forces are very much weaker than covalent or ionic bonds. So the strength of intermolecular forces are responsible for the physical properties of simple molecular substances such as melting and boiling point, and we are going to study two types of intermolecular forces, which is the first one is van der Waals forces and the second one is hydrogen bond. So what is van der Waals forces? Okay. Van der Waals forces can be divided into two, which is dipole-dipole forces and London forces, or also known as dispersion forces. So the intermolecular forces increase in strength according to the following, which is hydrogen bond is stronger than dipole-dipole forces and dipole-dipole forces is stronger than London forces. Okay, we can say that London forces is the weakest forces between these three intermolecular forces. So what is dipole-dipole forces? Okay, dipole-dipole forces is attractive forces between neutral polar molecule, which is kalau if the molecule is a polar molecule, dia akan ada dipole-dipole forces. So the forces arise from the attraction between partial positive charge on one molecule and partial negative charge on the other molecule. So chlorine is partially negative and hydrogen from the other molecule is partially positive. Okay, so partially positive and partially negative, they akan ada dipole-dipole forces. So there's another example of dipole-dipole forces is between H2S. So dipole-dipole forces, okay, that arise from the partially positive of hydrogen and partially negative of sulfur. So next we discuss on about London forces. So London forces exist in all atoms and molecules. Okay, it doesn't matter whether it is polar or non-polar. Okay, alright. So on average, the negative charge of electrons in the atom or molecule is spread evenly around the nucleus. So at any instant, okay, one side of the atom or molecules has higher electron density than the other side. At this instant, the atom or molecule become a small instantaneous dipole and then induce a dipole on neighboring atom and molecule. Jadi dia akan ada apa? Daya yang sementara. Okay, right. So the induce dipole on the neighboring atom molecules. Jadi macam mana dia induce? Dia akan mengaruh lah, because this is partially negative. Okay, so dia akan induce the non-polar molecule. Due to the electron repulsion, instantaneous dipole on one atom can induce a similar dipole on neighboring atom, which can cause the neighboring atoms to be attracted to one another. Okay, jadi dia akan tertarik di antara satu sama lain. So this interaction is called the London forces or dispersion forces, and only significant when the atoms are very close to one another. Okay, so dia cuma wujud sekiranya this non-polar molecule berada pada keadaan yang rapat. Okay. Alright. So this is an example of London forces in chlorine. Okay. Chlorine is non-polar molecule. So non-polar and non-polar, dia akan ada London forces. Alright. So the example. State the types of intermolecular forces exist between each of the following molecules. Jadi kita tengok dahulu. Okay, BF3 is non-polar. Jadi kalau di non-polar, dia mempunyai London forces. Next, we have CO2. Okay, CO2 is a non-polar molecule because the resultant is cancelling by each other. Okay, left and right. So linear, it has London forces. Okay, so CHCl3 is a polar molecule. Okay, because the cancellation does not occur. Okay, dia tiada berlaku pembatalan polar. Jadi dia akan pergi ke arah carbon. Okay, and then this one directing to carbon. Okay, direct to carbon, and hydrogen direct to carbon. So the resultant dia akan pergi ke bawah. Okay, so CH3 is a polar molecule. Jadi kalau dia polar molecule, dia mempunyai dipole-dipole forces. And then CCl4 is non-polar molecule because dia berlaku cancellation, okay? Pembatalan atas satu, kiri, kanan dan ke bawah. Jadi dia ada apa? London forces. Okay, next kita tengok hydrogen bond. Okay, hydrogen bond is a strong attraction between the positively charged hydrogen atom of a molecule and negatively charged electronegative atom such as fluorine, oxygen and nitrogen atom of the other molecule. Jadi hydrogen bond ini dia cuma wujud di antara hydrogen, okay, dengan these three atoms which is FON, fluorine, oxygen, nitrogen. Jadi kalau hydrogen fluoride dia boleh wujud hydrogen bonding. Okay, di antara satu molekul hydrogen fluoride and another molecule of hydrogen fluoride. Okay, so this is positively charged hydrogen atom. Okay, partially negative. This is partially negative. So partially positive and partially negative, dia ada daya hydrogen bond. Okay, so it's very simple for us to discuss dekat sini. Okay, dalam H2O dia boleh berlaku. Ini satu molekul water, and then this one another molecule of water. Jadi di antara dua ini dia ada hydrogen bond. Okay, because dia adalah hidrogen yang ada ikatan dengan oksigen. So this one FON. Tadi kita dah hafal FON. Jadi fluorine, okay, fluorine, oxygen, nitrogen. Jadi in this case we have nitrogen. Jadi nitrogen and hydrogen dia boleh menghasilkan daya hydrogen bonding. Okay, alright. So between water dan juga ammonia. Okay, so this one is H2O, this one is ammonia. Jadi dua-dua akan menghasilkan, okay, dua-dua akan menghasilkan London hydrogen bond. Okay, alright. So dekat bawah ni pun sama juga. Okay, ammonia and water, then HF and ammonia, okay, HF dan ammonia, and then NH3 dan HF. Jadi maksudnya di sini, as long as dalam molekul itu ada daya di antara hidrogen dan juga fluorine, hidrogen dan oksigen, hidrogen dan nitrogen. So ketiga-tiga keadaan ini boleh mewujudkan hydrogen bond, which is HF ni dengan another neighboring atom. Okay, alright, neighboring molecules. Okay, hydrogen bond in organic compound. So ini adalah example hydrogen bond di dalam organic compound such as carboxylic acid, okay, dan juga yang ada hydrogen bond. Okay, because dalam carboxylic acid kita ada O dan juga H. Okay, dalam alkohol kita ada ammonia, kita ada OH, okay, hydroxyl, Jadi OH dia boleh form hydrogen bond. And then dalam amine, okay, amine dia ada nitrogen dan hydrogen. Okay, kita kena ingat yang tiga tadi iaitu fluorine, oksigen dan juga nitrogen. Okay, so next, okay, kita pergi kepada the next part which is metallic bond. So the metallic bond in this topic, okay, you should be able to explain the formation of metallic bond by using the electron C model and explain the factor that affect the strength of metallic bond. Okay, kita akan menerangkan faktor yang mempengaruhi kekuatan metalik. Okay, alright. So metallic bond, okay, in a metallic structure, metal's atom can be imagined as an array of positive ions immersed in a sea of delocalized valence electron. Okay, kita boleh bayangkan dia seperti, okay, sebaris positive ion yang tenggelam di dalam lautan electron valence. Okay, jadi metallic structure also known as electron C model. Jadi ini adalah example untuk electron C model. Okay, kita ada charge positive and charge negative which is came from electron. Okay, positively charged metal ion. Jadi positive and negative dia akan menghasilkan daya tarikan yang dipanggil metallic structure. So metallic structure or a metallic bond can be defined as the electrostatic force between the positively charged metal ions and the sea of delocalized electrons. Okay, so maksudnya di sini dia adalah daya, okay, elektrostatik di antara metal yang bercharge positif dan juga lautan elektron yang berada di sekeliling metallic bond. Okay, di sekeliling metallic element. Okay, so this one is an example of metallic structure of sodium. Sodium will release one electron, one sodium atom will release one electron. Jadi dia akan dapat daya electrostatic between positively charged and negatively charged. So electron C model of magnesium. Okay, magnesium we have Mg2+. So dia ada dua valence electron. Okay, jadi semakin banyak charge dan semakin banyak electron valence, dia akan semakin kuat. This one is for aluminium. Aluminium kita ada 3. Okay, so 3 valence electron for aluminium, dia akan berlaku electrostatic force yang dipanggil apa? Metallic bonding. Okay, alright. So semakin banyak electron valence, dia semakin kuat metallic bond. Okay, because metallic bond is influenced by the number of valence electron of the metal element. Okay, the properties of metal, the first one in electron C model. Okay, metal ions can be easily slide over each other to a new lattice position when a sufficient force is applied. Therefore, metal can have the ability to deform or pressed into different shapes under compression, okay, yang dipanggil malleability. Okay, right. And then it can be stretched or pulled into a wire, yang dipanggil ductility. Okay, right. So properties of metal: due to the presence of delocalized electron which can be moved freely over the entire metal, mobile electron can act as charge carries in the condition of electricity, okay, which is electrical charge. And then energy that carries in the condition of heat, yang also known as heat conductor. Okay, alright. So next, the last part kita discuss tentang factor that affect the strength of metallic bond. As I mentioned earlier, okay, the strength of metallic bond depends on the number of valence electrons and the size of positively charged metal ions. Okay, so semakin banyak number of valence electron, semakin kuat metallic bond. Okay, so from sodium to aluminium, sodium will have one valence electron. Magnesium ada 2 valence electron, and then aluminium ada 3 valence elektron. Jadi kalau ketiga-tiga ni, okay, yang paling kuat sekali adalah aluminium lah, because dia ada apa? 3 valence elektron. So the strength of metallic bond is depends on the number of valence electron, which has higher boiling point between sodium and magnesium. I'm going to explain. Okay, sodium has 1 valence electron, magnesium you have 2. Yes, good. Okay, so magnesium ada 2 valence electron. Jadi the strength of metallic bond is directly proportional to the number of valence electron. Thus magnesium has the stronger metallic bond than sodium. Okay, then the last part is the strength of metallic bond. So the size of positively charged metal ion which has higher boiling point between sodium and calcium. Explain your answer. Jadi kalau kita tengok di sini, sodium ada 1 valence electron. Okay, potassium pun ada 1 valence electron. Jadi macam mana kita nak tahu a stronger bonding point? Say both has 1 valence electron because both are element in group 1. Jadi sodium ion has smaller size than potassium. So the strength of metallic bond is inversely proportional to the size of positively charged metal. Okay, which is, ini adalah hubungan di antara apa? The strength of metallic bond dengan the size of the number of valence electron. Okay. Jadi semakin banyak number of valence electron, dia semakin kuat dia punya metallic bond. Okay, so that's all for chapter 4.4. Thank you, class.